I'm Alana, and this is my video number 2 on homework 1.4.
Okay, first off, we have question number 5, which says, find the area of the region bounded by r equals 6 cosine 6 theta in between 0 and 2 pi. So here we need to use the area formula, which is area equals 1/2 of the integral from alpha to beta of r squared. Now, in the case of this problem, we're just going to replace r with our value right there. So we have area equals 1/2 the integral from 0 to 2 pi of 6 cosine 6 theta. And we're going to do this whole thing squared d theta. And now I'm just going to plug this into my calculator. So, I'm going to start with 0 to 2 pi. And we are going to do 6 cosine 6 theta squared d theta. And we get this value, but we have to remember that we have our 1/2 in front here. So as soon as we divide this number by 2, we get our real answer, which is going to be approximately 56.55. Perfect. Now on to the second problem. We have number 9, which is find the length of the entire perimeter of the region inside r equals 9 sine theta, but outside r equals 2. So this problem is a little bit tricky, so I graphed it on Desmos so to have a better visual. So this outer circle right here is r equals 9 sine theta, and the inside is r equals 2. So our first step to solving this problem is we need to find where the two circles intersect so that we can add up the perimeters. So when we set these problems equal to each other, we get 9 sine theta equals 2. And we're trying to find theta, so we divide both sides by 9. And theta equals arc sine of 2 over 9. Now, instead of doing this in the calculator, what I'm going to do is I'm just going to set this value as a. So I'm going to put a equals arc sine of 2 over 9. And then what I'm going to do is use our perimeter formula, or the arc length formula, which is equals beta or alpha square root of f of theta squared plus a derivative squared, and that's all going to be in a square root, and that is our formula. So what I'm going to do here is I'm just going to plug in our first r value, which is going to be r equals 9 sine theta, and the derivative of this is 9 cosine theta. And now let's just do this one. So our value is 2 and the derivative is going to be 0, so we know for that. Okay, so for our first r, I'm just going to plug in 9 sine theta, and I'm going to sort of be working on the middle, but for our outside values, I'm going to be doing from a to pi minus a, because we want the distance from a over here all the way to pi minus a, which is right on the opposite side. So anyway, we have square root of 9 sine theta squared plus 9 cosine theta squared. And when we expand this, we get s equals the bounds and this expands to 81 sine squared theta plus 81 cosine squared theta. And this simplifies. The sine squared theta and cosine squared theta we can combine. So it just becomes a square root of 81 because sine squared theta plus cosine squared theta is 1, which equals to 9. And then for doing the bounds, pi minus a is pi minus 2a. So we can just write it like that because that is equivalent to the distance there. So our first value is going to be 9 times pi minus 2a. And we're just going to do the same thing for the other r value, which is 2. I'll try to fit it into this side. 2 squared plus 0 squared. Sorry, and our bounds are also going to be pi minus a and a. And we're just going to get the square root of 4. So that's just going to be 2. And then we're going to get basically the same thing as for the 9 one, except our s is going to be 2 pi minus 2a. So from here, what I'm going to do is we need to add both these numbers to get the total perimeter. So it's going to be 9 pi minus 2a plus 2 pi minus 2a, which just equals to 11 pi minus 2a. And from here on, we can plug arc sine 2 over 9 into a to get our answer. So I'm going to do pi minus 2 times arc sine 2 over 9. There we go. And now we have to multiply it by 11. And we get 29.627. So our answer is going to be roughly 29.63. And these are our two answers right here.